Next, we're asked to write the expression for the flux d phi b through a phi sub b through a narrow strip of length L parallel to the axis of width dr at a distance r from the axis of the cable and lying in the plane containing the axis. So let's begin with what they tell us. D phi b, that will actually equal magnetic field dA. But we have B from here, so let's plug that in. And dA equals L dr. So this gives us d phi b equals mu naught I over 2 pi r dr. This is our equation. So part C, integrate your expression from part B over the volume between the two conductors to find the total flux produced by current I in the central conductor. So let's integrate. When we integrate the left side of this equation, we will get, I forgot to put this as phi. Phi b, which is the flux, magnetic flux, and we will get the integral of the right hand side. Okay, so we're also told that, I forgot from here, LDR, I forgot to place it here. I forgot to place LDR here. So let's move all of our constants to the left side of the integral. Mu naught I over 2 pi integral, and L, don't forget L, 1 over r dr. Solving this integral, we get natural log of r from A to B. We were told over the volume between the two conductors to find the flux. So that would be from this point to that point. So it'll be from A to B. Next, we simply just to make it clear, natural log of B minus natural log of A. Okay, next, calculate the inductance per unit length. L over small l for the cable. Now we know that L will equal the magnetic flux over the current. And we're told that they want the length per unit, the inductance per unit length, so we will divide both sides by L. We have the magnetic flux from part C. This is part D. We have it from part C, so we just plug in. Two pi natural log B minus natural log of A all over current L. Now taking this, we can actually cross out IL, and our answer becomes mu naught over 2 pi natural log of the absolute value of B minus the natural log of the absolute value of A. And this is our inductance per unit length. So lastly, we calculate the energy stored in the magnetic field per unit length. The equation for the energy, U, stored in the magnetic field will equal 1/2 in inductance times the current squared. But they're asking per unit length. So we divide both sides by L to get per unit length. L over, L over, large L over sub L we have. So we can plug that in. We'll have equals 1/2 mu naught over 2 pi natural log of absolute value of B minus the natural log of the absolute value of A times the current. I'll put it here. And that is our answer. This is our answer, but I will just simplify it. Since we have 1/2, we can make this 1 over 4 pi mu. We can actually forget the I, the 1. It's going to be mu naught I over 4 pi times the natural log of B minus the natural log of the absolute value of A. Finally, yes, simplified. This is our answer.